So what I'm going to ask you guys to do is I want you to solve these first two equations for me. So in the chat, I want to see your answers numbered 1 and 2, and what are your answers for these equations. These are nice and easy, nice and basic, and you guys have been doing really nicely, so I want you to try them. We'll go through them together, but for now, I want you to try. Answers on the chat, and if you have questions, put them on the chat. I will ask for hands later, but I don't want hands now. Give these a try, answers on the chat, and if you have questions, on the chat as well. And remember, guys, the goal of an equation is to solve for x. So you want x equals a single value. Just want to turn my lights on here. Remember to number your answers, grade 8, so 1 and 2, because I have asked you to do 2 of them. What I'm actually going to do is I'm going to sorry, everyone. Panic. Laptop panicked. I panicked. Everyone panicked. I've just moved 2 over to this side here. Good, guys, keep those answers coming. And like I say, if you're struggling, ask on the chat. We're here to help you. Okay, I'm going to give you 1 more minute. Sorry, I don't, for whatever reason, my laptop is not showing me the time at this point, so it's fine. All right, remember, guys, we're not raising hands yet. We're going to wait until I've gone through them, and then I'll deal with any questions or concerns that you may have. Okay. All right, guys, let's do it. So the first one, honestly, you guys could probably just write down the answer. In a situation like this where it is quite an easy equation, you can't just write down the answer. There's very little working out that really needs to be shown here. This is one where you can look at it and you can automatically tell me what the answer is. So this is an equation where we could solve this by what we call inspection, looking at it, telling me the answer straight away. However, if we want to apply what we do know about solving equations, we know that we have to use inverse operations. What that means is that this +2 needs to essentially move across the equal sign so that we can get x alone. And if that's going to happen, we need to use inverse operations, which means it must become -2. So this would be x is equal to 10 minus 2. And so, yes, exactly as all of you have said, x is equal to 8. Now, on the other side here, what we need to be mindful of is that this is a slightly harder equation. It's not as easy to look at this and say, oh, okay, I know what the answer is. X is equal to whatever. We need to do a little bit more work here. Now, once again, inverse operations is the golden rule of equations. That's what we need to apply. +4 needs to essentially come over the equal sign. So we're going to subtract 4 on both sides. If I'm subtracting 4, remember, guys, +4 minus 4 is 0. That's what gets rid of the 4 on the left. And so what we're left with is 6x is equal to 22 minus 4. And we know that 22 minus 4 is 18. Now remember, the goal is to solve for x. What I see is that I've got a coefficient. So this 6 is my coefficient. And anytime, grade 8, anytime there is a coefficient of anything other than positive 1, we have to divide both sides by that coefficient. Because again, the goal is to get x alone. 6 divided by 6 is 1. So that allows me to get x by itself. And then I've got 18 divided by 6, which gives me 3. Now these were quite easy, and this was more to ease us into and to remind us of inverse operations. Now guys, just quickly as a reminder, please remember that you can always check your answers. So whenever you are sitting at the end of a test and you're not really sure what you should be doing with your time, you should be checking. So a check basically involves you wanting to check that the equation is actually true, that the left-hand side is equal to the right-hand side. And to check, you use substitution. So if we look at our first equation, we will substitute 8 in place of x, because that's what we solved x for, plus 2 on the left is equal to 10. Now 8 plus 2 is 10. And so because the left-hand side, LHS, is equal to the right-hand side, RHS, that value of 8 for x is correct. That's how we check. If I look at number 2, if I'm going to do a check here, we're going to say, whoopsie daisies, we're going to say 6 times 3, because that's what we solved x for, plus 4 should equal 22. 6 times 3 is 18. 18 plus 4 on the left-hand side is 22. 22 is equal to 22, so the left-hand side is equal to the right-hand side, and so x equals 3 is correct. So really importantly, grade 8, you should never not be checking your answers for equations. There is a way to check. It is easy to check. You should be checking to make sure that you're getting 100% for these questions. So take your screenshots. If anyone has any questions, now is the time to raise your hand and ask me. Otherwise, we're going to move on and have a look at the next couple. So again, if you've got questions, feel free to raise your hand and I will help. Okay, no questions. So I'm hoping you've all got your screenshots, and then we're going to move on. Okay, so if we have a look, this is now obviously changed to question 2 because technology doesn't really like me, which is fine. I'm not going to take it too personally. This is example 3. Right, so example 3. Kindly now it wants to be a table. Okay. If we now have a look at this, what we have is a situation where we've got x's on both sides of the equal sign. And again, this is something you need to be able to deal with. So again, I'm going to ask you to solve for x here. Remember what I've said to you in the past is that what we want to do is we want to get all of our x terms to one side, constants to the other side. Now, it doesn't matter which side you put the x's on and which side you put the constants on. I usually, just to keep it the same and consistent, I usually say get your x terms on the left, get your constants on the right. But it doesn't matter. As long as you use inverse operations, you will get the same answer. And the reason I'm being quite clear on it doesn't matter is because some people don't do it the same way that I do it. And that's fine. Like, there are different ways to solve an equation. So if you're going to put your x terms on the right, that's absolutely fine. If you're going to put your x terms on the left, that's also absolutely fine. There is no one singular way to do this or to really to do anything in maths. So try this. I'm going to wait for some answers on the chat and then we'll go through it together. And remember, guys, once you've got an answer and you're waiting for everyone else, do a check. Make sure that you agree with your own answer. Again, grade 8, like I said, once you've got your answer, do a check. Make sure that you agree with your own answer. Good, guys. Okay, so let's see. So again, I'm going to put my x's on the left. You don't have to. If you've put them on the right, that is fine. If I'm going to put them on the left, what that means is that this this 4x needs to come over and join the negative 2x. That means it will become minus 4x, inverse operations. But in the same way, this positive 12 needs to move over and go to the right-hand side. So it's going to become minus 12. What that means is I've now got negative 2x minus 4x on the left is equal to negative 12 on the right, because remember I brought that 12 over. Minus 2x minus 4x gives me minus 6x is equal to negative 12. Now again, I've got a coefficient here that I don't want. I'm going to have to divide both sides by that coefficient of negative 6 in order to get x alone. And now very importantly, guys, a negative divided by a negative is a positive. So x here is equal to 2 because 12 divided by 6 is 2. Now, just to very quickly show you why I'm saying that it makes no difference which side you put your x's on or your constants. If we have our equation of 12 minus 2x is equal to 4x, and we decide to rather take this minus 2x and let it join the 4x, becoming plus 2x. What you will have is your numbers or your constants on the left, so 12 is equal to 4x plus 2x, inverse operations. 4x plus 2x is 6x. And again, we don't like that coefficient there. We obviously need to divide it away. So I'll divide both sides by 6. 6 divided by 6 is 1. And so we end up with 12 with 2, because 12 divided by 6 is 2, is equal to x. Those are exactly the same answer. In both cases, you are telling me that 2 is the value of x. And so that's what I'm saying. It doesn't actually matter which side you choose to put your x's on and which side you choose to put your constants on. If you are correctly applying the maths and if you are correctly doing your inverse operations, it doesn't matter. You will get the same answer. And so if you're more comfortable doing it the second way or the way on the right, do it. If you're more comfortable doing it with the way on the left, do it. Doesn't matter. Both are correct. Right, so take your screenshots. Any questions, you can raise your hand. Otherwise, we're going to have a look at, again, a step up, something slightly more complicated where we have to worry about or where we have to think about distribution. Okay. Good, guys. Okay, so apparently now my numbers have disappeared entirely. So that's, fun development that we've got going on here. This is question 4. And what we see that we've got going on in question 4 is we've got a bracket. Those are quite basic questions. From about question 4 now, we're starting to level it up and get slightly harder. So guys, like I was saying, question 4, what we see is we've got brackets. So what that means is we've got distribution. So very importantly, whenever there is distribution, we have to do that first. Okay, it's just going to make our life easier further down the line. It means that we don't have those brackets that we need to worry about, and it means that we can get all our terms as they should be, and we can then go from there. So I need to distribute the 2 into the bracket. And remember, distribution means times. So I've got 2 times x, which is 2x, and 2 times 2, which is positive 4. And then this is a situation that we're quite comfortable with. We know how to solve this equation and we can go and do that. So I want you guys to finish this off for me. And for this one, I am going to ask for hands for answers. I don't want hands yet, so please do not put up your hand. But if you feel like you are feeling comfortable to give and explain an answer when I ask for hands, please do put up your hand right now, get an answer for me, and we'll have a look in a second. No hands yet, guys. I only want to see hands when I ask for them. You can put your answers on the chat. That is absolutely fine. And if you have questions, you can also put them on the chat. Remember, if you do have an answer, you need to check your answer. Make sure that you agree with the X value you've given. Hey guys, don't panic. I'm going to come back to this. I just want to check something very quickly. Make sure you're checking your answers. You don't have to write the check out neatly. It's just on a scrap piece of paper, or quickly in pencil, or quickly with your calculator. Make sure you are checking. Alrighty, who would like to explain how to solve this equation? Hands up. So if you want to explain, you can raise your hand. Okay, Motsbang, explain this one for us.
Okay, ma'am. So we take x to the other side in inverse, so it's 2x minus x, and we take plus 4 now to the other side into equals, which makes it plus 2 minus 4.
Good.
2x minus x is x, and 2 minus 4 is negative 2.
You cut out there, Motabang, but I'm hoping that that was what you said, that 2x minus x is equal to x, and 2 minus 4 is minus 2. And so exactly as you worked out, x is equal to negative 2. Wonderful. Thank you, Motabang. Very nicely explained. And guys, I hope you heard how Motabang very clearly told us that we need to use those inverse operations. So exactly, the positive x needs to become minus x. The positive 4 needs to become negative 4. Alrighty. So that is essentially how we go and find the solution. Again, guys, unfortunately saying, I don't know, I don't understand, I don't get it, I need something specific, and then I can help you. But if you just say, I don't get it, then I don't know where exactly you've gotten lost. So with that being said, if anyone has any questions about this, please raise your hand and I will help you. But again, specific questions. Unfortunately, I can't reteach an entire section in an answer. So tell me specifically where you've gotten lost and I can help you. If you don't have questions, you're taking your screenshot and you're marking. and then we're going to have a look at one more before we take a brain break. Alrighty. Oratile, those 3 dots mean therefore. So in maths, we can't have 2 equal sign on the same line, because like an equal sign is saying one side is equal to another side. We can't have a whole bunch of things just being equal. So what we do is, to show that we've gone on to the next step, we use the 3 little dots, which means therefore. Right, I'm explaining this one more time, so please listen if you are confused about where something has come from, if we've gone from one thing to another and you don't understand. So listen, I'm going through it again. So first things first is the second there is distribution, or the second there's a multiplication, that's what we do first. So we take this 2 and that gets multiplied to the x and to the positive 2. So 2 times x is 2x, 2 times 2 is 4. That was the distribution. Once we had done that, remember what we want to do is we want to get all our x terms together and all our constants together. So this positive x, it needs to come over to join the 2x, but it becomes minus x. So that's why I've got a minus x in my next step. In the same sort of idea, this plus 4 needs to come over to join the 2. And so again, using inverse operations, it becomes minus 4. And that's why I've got a minus 4 in the next step. You now have like terms on either side of your equation. 2x minus x, or you can imagine the 1 there. So 2x minus 1x is just x, and 2 minus 4. Think of your number line. If we are here at positive 2 and we're subtracting 4, we end up at a negative 2. So that is why my answer to x is negative 2. So again, I've used inverse operations. I've grouped my like terms on either side of the equal sign, and I've solved. Okay, so those of you asking, I hope that makes more sense. Retabile, last question.
Hi, ma'am.
Hi.
I wanted to ask you that why are we minusing the 4?
Because remember, we have to use the opposite operation. It was plus 4 on the left, so it has to become minus.
Oh. Thank you.
There's ya. Right, grade 8. So I'm glad to see that people are correcting. I hope that has answered the questions for those who were a bit confused or wanted it re-explained. So I want to look at this last one before we take a little break. Okay, so this last one is very similar to question 4, except now we've got 2 sets of distribution. Now, what often trips us up in questions like this one specifically is the very first thing. Please remember that this minus sign separates my terms. This positive 1 is a term all by itself, and then the minus times the bracket is a completely separate term. So when it comes to the distribution, remember we do have a 1 in front of the bracket. So what we're going to do is we're going to distribute minus 1 into the bracket. And please remember that I said this in our lesson last week, Wednesday. Please, Wonderwalker, I will go back in a second for you to take a screenshot. We're just going to do this one and then I'll zoom out and we can take screenshots of both. So guys, like I said in our lesson last week, Wednesday, please remember that firstly, if there was just a negative in front of the bracket, there is a coefficient of -1 that has to be distributed. And secondly, and I've said it again in this lesson, distribution has to happen first. That first one is a term completely separate to the one with the bracket. That is going to stay 1 until we start to add and subtract like terms, or we start to deal with putting constants on one side, variables on the other. The distribution has to happen first. On the right-hand side, a much easier distribution, it's just the 2 into the bracket. But like I've just said, this positive 1 stays 1. I'm not doing anything with it yet. I have to do the distribution first. So I've got minus 1 times 3x, which gives us a negative 3x. And I've got minus 1 times positive 4, which gives us a negative 4. That is equal to 2 times 4x, which is 8x, and 2 times negative 6, which is negative 12. So you've done the distribution. Now you can start stressing about where that 1 fits in. So guys, if we think about this, what we want to do is we want this 8x to come and join the negative 3x. That means it's going to become minus 8x. And we also want the 1 and the negative 4 to come and join the negative 12. So the positive 1 becomes minus 1. The negative 4 becomes plus 4. They are going to move to the right-hand side so that all of my numbers are on the right. That means on the left, I've got the minus 3x. And now because I brought the 8x to join it, it's minus 8x is equal to the negative 12, which was originally on the right. I didn't do anything with it. Minus 1, because I'm bringing this 1 to join on the right-hand side, plus 4, because I'm taking this negative 4 and I'm moving it over. You can see now all the x's on the left, all the constants are on the right. So we're at minus 3x. I want to subtract 8x, so that takes me all the way down to a negative 11x. And then we've got minus 12 minus 1 plus 4. Now don't panic about this. I have not done this number line very well, so I'm just going to reattempt that situation. Okay, so here I am at negative 12. I subtract 1, taking me down to negative 13. But now I add 4. 1, 2, 3, 4. So my final simplified constant term is negative 8. Again, guys, you don't want this variable. So what we want to do, this variable, this coefficient, so what we need to do is we need to divide both sides by the coefficient to get x alone. And remember, firstly, about your signs, which we'll discuss in a second. And secondly, fractions are okay. So what we have is negative 8 divided by negative 11, and negative divided by negative is a positive. So we have positive 8 over 11. Ma'am, it's minus 9. I don't know if I'm just being incredibly stupid. What's minus 9? Minus 12, minus 1 is minus 13. Oh, yes, with you. Yes, thank you, grade 8s. Thank heavens you guys are on it. I apparently can't draw a number line. That's my issue. Should be 13, 12, 11, 10, 9. Thank you guys, you're on it. So yes, so sorry, this should be a negative 9, which means we've got 9 over 11. Thanks, grade 8s. I'm glad you are on top of it. All right, excuse me. So what I did, or my oopsie here, was I drew the number line incorrectly. So minus 12 minus 1 is negative 13. Negative 13 plus 4 is negative 9, not negative 8. Thank you very much. But what I was saying still applies. Negative divided by negative is a positive, and fraction answers are fine. We don't like fractions a whole lot, but they are fine as answers to an equation. Okay, so I'm going to make that smaller so you can screenshot both. And whilst you're screenshotting, if anyone has any questions, now is the time to raise your hand and ask. Okay, so guys, questions, please raise your hands and ask. Otherwise, clearly my brain needs a break. So we're going to take a brain break and then we're going to carry on with some fractions. Okay. Right. So brain break today, you know how this works, hopefully by now. We do a lot of these, and this is solving an equation. This is what I've been saying to you the whole time. So what I want from you guys, remember, is the value of this very last equation down at the bottom. I don't actually know what this last animal is. I want to say it's like a rabbit, but I have no idea. I'm assuming this is a cat, and this is obviously a frog. Let's call that last thing a rabbit, because I honestly don't know what it is. So I want the value of the very, very last equation there. I will wait for the correct answer, and I need to do it myself. But whoever gets it right, you know the drill. You will explain it to all of us. And remember, guys, you're welcome to help each other in chats like Alicia's doing there. Help each other out by getting some answers in. Oh, Teto, well done. Teto was our first one. Nkululeko very close behind, but Teto, if you want to raise your hand and explain it.
Oh, yeah, that was so fast also.
Yeah.
Well done.
Okay, Teto, tell us. Oh, did I not unmute you? That's entirely possible. There we go. The unmute thing should pop up. There we go.
Hello, ma'am.
Hi.
So ma'am, for the cat, it is 27 divided by 3, which ends up being 9. So the cat is 9.
Good.
What? Can you leave me alone? Oh, okay, so you wrote that part in. So it ends up being 9 times 9, since you have to focus on multiplication first. And
Good.
that becomes 81. So 89 minus 81 is 8, which makes the frog 8.
Good.
Ma'am, then this one took me a little while, ma'am. So I know that, for starters, I know that the 2 frogs at the very start is 16. And I know that the 2 frogs at the very end are 16. So since I couldn't really work out the rabbit yet, I decided to try working backwards. So I said 176 minus 16 because I'm trying to get slowly down. It's kind of like solving for x. So I ended up with 160. And then from there, I just knew that for me to go from 16 to 160, I needed to multiply it by 10. But since there were 2, that makes it's either a rabbit or a bunny, I believe. It makes one of them, it makes it 5.
Good.
So it makes the sum at the very end, makes it 9 plus 16 times 5. So we have to start off with multiplication first. So it ends up being 16 times 5, which makes, think it as 80.
Good.
And then at the very end, 80 plus 9, 89.
Excellent. Well done. And guys, I hope you all heard what Teto said there. It is solving an equation. That is what these things are. Yes, there's frogs and cats and hippos and all the rest of them, but they represent an unknown. And so what you're doing here is you're solving an equation. And so exactly like Teto said, work backwards, use your inverse operation knowledge to solve these things.
What?
Very, very nicely done.
I don't even.
Okay, guys, so brain break. And like I mean, I've been saying this to you the whole year, and I keep saying, oh, when we get to equations, this will become easier. I'm hoping these are becoming easier because it is solving an equation. Righto. Let's have a look. Someone's very upset that someone's walking in the road when there's parkings, but whatever. Let's have a look at this one. So like I said, we're going to have a look at a couple examples with some fractions because especially as you start to, if you decide to do maths in grade 10, the algebra involves a lot of fractions. So as much as we don't like fractions, we do need to be able to deal with fractions. Okay, so here we've got x divided by 4 equals 5. Now again, most of you can probably look at this, tell me what the answer is immediately, but we do need to get into the habit of doing our inverse operations. Okay, so please remember that this fraction is telling us that we are taking the value of x and we are dividing it by 4, and whatever that is should be equal to 5. Okay, so our inverse operations tells us to do the opposite of the original. So here our original operation is division, which means that we need to do multiplication in order to get rid of the division. If I multiply by 4, I no longer have a fraction. But if you're going to multiply the left by 4, you need to multiply the right-hand side by 4. And so what we have is x is equal to 5 times 4, which as all of you are saying there on the chat, is equal to 20. Now, very quickly, guys, because there was a question in the last class and I don't want anyone to be confused. If you're taking x divided by 4 and you're timesing it by 4, remember that 4 is technically over 1. So x times 4 gives us 4x. 4 times 1 gives us 4. So we've got 4x divided by 4. And simplification tells me that 4 divided by 4 is 1. So you're left with 1x or just x. That is why we times by the denominator. Timesing by the denominator essentially gets rid of the fraction, and so we just have the variable. Okay, like Lwandle is put there on the chat, remember to double check yourself. Whew. If you substitute back in, 20 divided by 4 is 5. So we've correctly solved for x here. So really importantly, guys, when there's a fraction, remember that the opposite operation is now to multiply. So quickly take your screenshots. I'm hoping there's no questions, but if there is, obviously, please feel free to raise your hand. But we're going to move on to slightly more complex fraction questions so that we can see how we're more likely to be given these questions. Okay, so screenshots, again, questions if you have any. I think you're fine, but see if you've got questions asked. All right, so I'm going to skip that one. I want to do this one first. We'll come back to the other one. So here we've got 2x plus 3 divided by 3 equals 11. So again, let's break it down. This is saying to me that the whole expression 2x plus 3, the whole thing, that whole value, is being divided by 3. And once I've done that, I should get an answer of 11. Now, guys, whenever you've got a fraction, it is advisable to try and get rid of that fraction as soon as possible. So that's exactly what I'm going to do. I know that dividing by 3 has an inverse operation of timesing by 3. And so I'm going to do that on both sides of my equation. That gets rid of my fraction on the left-hand side, leaving me with just 2x plus 3 is equal to 11 times 3, which is 33. Now I can start doing all of my inverse operations that I know how to do. I want to take that positive 3 that's currently on the left-hand side, and I want to make a join the 33. So I'm going to have to subtract 3 on both sides. That leaves me with 2x is equal to 33 minus 3, which we all know gives us 30. I'm solving for x, so I don't want that coefficient there. I need to divide both sides by 2. And so I get that x is equal to 15. Now again, double check yourself if you're not sure. If we substitute 15 in place of x, we've got 2 times 15, which is 30. 30 plus 3 in the numerator, which gives us 33. And so we have a fraction of 33 divided by 3. And we all know that 33 divided by 3 is 11. So this answer of x equals 15 is correct. So again, grade 8, when there's a fraction, we need to get rid of the denominator, or we need to get rid of what we're dividing by using multiplication. That is division's opposite or inverse operation. All right, so take a screenshot of that. I'm going to go back up to that question 2. We're going to give it a try. Just because for question 2 is not hard, but sometimes the format throws us off of how the question is presented to us. So I just want to chat about that in this question. Right, if you don't get a screenshot, that's fine. What I'll do is I'll make this smaller once we've done question 2, and you can take a screenshot of 2 and 3. Okay, so guys, this question I'm going to get you to try by yourselves, but there's something I want to chat about here. So we've got a half x plus 7 equals 0. Now, if you are fine with that coefficient of a half, that's cool. You don't have to stress about anything. Leave it as it is. But sometimes that freaks people out and we don't really know what to do with that. Now, please remember that all this is saying is a half times x, which is essentially over 1. And so that fraction of a half x could be rewritten as 1 times x, which is x, and 2 times 1, which is 2. So this first term, if you don't like the coefficient half and then x, you can rewrite this as x over 2 plus 7 is equal to 0. You don't have to, okay? I'm not saying you have to. I'm giving you an option if the coefficient of a half confuses or makes you feel uncomfortable. Another way to do it is to essentially write the x in the numerator or part of the same fraction. So I want you guys to try this one for me. I want an answer for x. Let's see what we get. Oh my golly. Remember, answers in the chat. I'm going to wait for answers. I'm going to give you a minute or 2. Double check your signs, guys. And if you don't know what I'm saying, check your answer. Tell me if your answer is correct. Yeah, so I'm seeing some close answers, but some of you again aren't checking or double checking your signs. So please do that. I'm literally giving away the answer here. I'm going to give you one more minute and then I'm going to go through it. Those of you that have answers, you should be using substitution to check those answers, making sure that you agree with your own answers, because some of you shouldn't be agreeing with your own answers. Good. Well done for checking. Right, guys, so let's have a look. So you have a few options here of how you want to do this. If you want to get rid of the fraction first and times by 2, that's fine. If you want to take the 7 over and then do the times, that's fine. I'm going to show you both because those would be the two main ways that you would do it. So if you decide, let me just get rid of this fraction right at the start, you would times this by 2, but remember you times everything by 2. You're going to times one term, you have to times all the terms. So that gets you your x by itself. But then you've got plus 17 times 2, which is 14, is equal to 0 times 2, which is just 0. You want that x by itself. So what that means is you need to take this positive 14 and it needs to essentially join the 0 on the right. What that means is I don't know, the English words didn't work there. What that means is it becomes a negative 14. So what we have is that x is equal to negative 14. If you didn't do it like that, so our question was x over 2 plus 7 equals 0, and you decided first you're going to take this positive 7 over and have x over 2 is equal to negative 7, that's fine. Because now what you would do is you would times by 2 to get rid of your fraction. And a negative 7 times a positive 2 is a negative 14. So this is what I was saying earlier, guys. Just because I do it a specific way doesn't mean you have to or are being taught the same way as what I'm doing. There are different ways to do exactly the same thing, all of which are correct. As long as you keep your inverse operations correct, as long as you keep like your signs and your multiplication and all those like basic math skills correct, you will get the right answer. So either way, however you've chosen to do it, you should have gotten x equals negative 14. And this makes sense. If you substitute back into your original equation, we do a quick check. We've got a we've got a half times x, which is 14, plus 7 should equal 0. Now a half times 14 is half of 14, which is 7. Oi. Help if I substitute in the correct value here. Negative 14. So a half of negative 14 is negative 7, plus 7 equals 0. And 7 minus 7 or minus 7 plus 7 is 0. So 0 is equal to 0, which means that our answer is correct. So please always remember when there are fractions, we need to multiply away the denominator. So I've just done that in case you need to take a screenshot.